A team of scientists out of China edited primate genetics in an attempt to make them autistic, and the results are fascinating. For the last 60 years, autism has been on the rise for a lot of reasons, some of which we don't fully understand.
Autism rates have hit a record high, according to new CDC data released this week, showing about 1 in 31 children in the U.S. are diagnosed with autism spectrum disorder by their 8th birthday.
But because autism is rising, scientists have been looking for more effective treatments. And that's where these little guys come in. Zilong Chao, a researcher at Shanghai Jiaotong University, designed an experiment that would edit a monkey's DNA to make them replicate autistic symptoms. With this gene, MECP2, the human mutated version of this gene would be injected into the embryo of a monkey, which was followed by artificial insemination and implantation of the embryos into the surrogate mothers. But why was this specific gene used? Well, MECP2 plays a crucial role in transcriptional regulation and microRNA processing, which are fundamental processes for brain development and function. On top of that, 90% of people who have Rett syndrome have a mutation in this specific gene, and like autism, Rett syndrome plays a huge role in brain development. And by injecting this mutation into an animal that shares so much DNA with humans, unlike rats for instance, we might be able to learn about autism from a different standpoint and develop more treatments for it. So after injecting 53 embryos into 18 mothers, 8 alive monkeys were born. So what happened? Autism spectrum disorder is a developmental disability that affects the brain. Autism is a spectrum, so many people who have it have many different symptoms. But there are a few core symptoms most autistic people share. The biggest difficulties are with communication, lack of eye contact, sensitivity to noise and external stimuli, and more. So, can monkeys be autistic too? Well, these monkeys had strikingly similar traits to humans with autism. One monkey had a very repetitive behavior, which was described as obsessively circling their cage. A few other monkeys had very high anxiety. As a researcher reported, the monkeys made grunting or screaming noises when approached by the researcher. And they all lacked social interaction. They all often ignored each other during social tests at age 1.5, and by age 3, they all avoided sitting next to each other, which isn't normal for these monkeys. After that, researchers wanted to see if these traits would get passed down to offsprings of these monkeys. So they decided to make a second generation, but not in the normal way. They extracted sperm from these monkeys, injected the sperm under mice skin to speed up maturation of the sperm. This way, it would only take 2.5 years to create the next generation of monkeys, instead of 6 years. When the monkey sperm was injected into the mothers, 5 new monkeys were born. Once these 5 monkeys reached the age of 1 year old, the same exact symptoms were noticed in them. They avoided all social interactions, had very high anxiety, and some had very repetitive behaviors, proving that these traits can be inherited. On top of this, the monkeys' brains were scanned by fMRI machines, and the results were groundbreaking. These scans revealed unusually low connectivity across some long-range circuits and within the thalamus and striatum, and enhanced connectivity in the somatosensory cortex, as well as changes in the cortical and subcortical volume by MRI. These monkeys exhibited abnormal brain development, including reduced gray matter volume and cortical thickness in specific brain regions. So with all this knowledge, can we create a more effective treatment for the many people affected by the rising case of autism? Well, no treatments were given to the monkeys themselves, but This experiment did teach us a lot about a disorder we know so little about, such as that the MECP2 gene plays a giant role in autism. It showed how the brain is affected by this gene mutation and confirmed that autism is inheritable, which we can use to make more effective treatments. Ever since this experiment, VR for social skill training has been developed, which has allowed people who struggle with socializing to work and get help at social skills, as well as wearable devices. Wearable technology is being explored to monitor behaviors and emotions in individuals with autism. These devices can track psychological responses, providing real-time data that can inform adjustments in therapy and support strategies, as well as gene therapy. Gene-targeted therapies are being studied to address the underlying genetic components of autism. These approaches aim to modify gene expression to correct abnormalities associated with the disorder, potentially offering more precise treatments. The timing in which autism treatment is given is super important. Many people who go undiagnosed as kids can develop severe depression as adults, as well as severe burnout, and then this can just lead to a whole bunch of other problems. Which is why unemployment for people with autism is so high. So now that we know what autism is, and we know more about it, we can hopefully avoid that mistake of diagnosing people who are struggling too late and provide earlier and more beneficial treatments to them. And this experiment really opened the door for us to analyze the brain and create a better treatment. Now, I will admit, this experiment probably wasn't the most ethical, and during this experiment, a lot of monkeys did die or were stillborn. And not to mention, many monkeys were very anxious during this experiment and were probably miserable, considering they were born neurodivergent. This experiment did also prove that with gene editing technology, autism could probably be cured. But I always remembered, autism is not a disease, and therefore cannot be cured. And if we did try to cure it, the results would most likely be very bad. But I want to hear from my autistic people out there. If you could cure your autism like that, if you could just make your autism go away with some simple gene editing, then would you do it?